Right, my name
Perfect,
is
thank you.
Christer Thorén, and I'm the product manager at Scania for the e-highways. Been doing that for quite some time. Here I share some history. I wasn't there 1890, but Siemens were, so they actually tried this technology quite early. However, 2012, I joined the project when we, together with Siemens, made the first truck with a pantograph. You can also see that by 2016, we were driving in snow in Sweden with 2 trucks. 2017, we had a high-level visit from Merkel, who joined our prime minister, talking about e-highways. 2019, Scania and Volvo together wrote this article in a big Financial Times of Sweden. Build e-highways now was a message. And also 2019, as you see to the right, we are driving in Germany on the big highway. So that's a very brief background where we are. And this is also in line with Julius' presentation. If we look at this graph now, we can see that to the left you see with the green staples there we have a lot of light vehicles, and to the right we have quite few heavy vehicles. Looking about how much you drive in the black, you drive almost the same distance. And of course the CO2 for the heavy vehicles are much more because they need more fuel per kilometer. So this shows you only, this is in Germany 2016. This mainly shows that even though you decarbonize the complete passenger car fleet, you still have a lot of CO2 to take care of. And even though the numbers are not equal in every country, you get the main message. We have to focus on the heavy vehicles. And that's where we are at Scania. So why do we think ERS, electrical system, is a good solution? It's quite simple. The battery vehicles, they of course require quite large batteries, but also they require quite big charging stations, because I would say that at lunchtime everybody will have lunch and charge the vehicles. So at that time you will have a huge demand of power. And with an ERS system you can actually have the same energy consumption, but with much lower power levels, because we smooth them out over the complete day while driving. And also, of course, we need less batteries, so it will make the vehicle cheaper, lighter, possibly shorter. In the beginning, we think that the hybrid is the better solution for an ERS vehicle, because the network might not be that big at the moment, and you probably want to drive quite long distances outside the ERS, the Catenary road. So that then the combustion engine is a better solution than the batteries if you want to go real long distances. But with a big network, of course, the battery vehicle is a good solution, probably a better solution, where you have shorter distances outside the ERS road. We can supply both. Both will be available from Scania. Looking at the German pilot, we at Scania got a contract from the German government to supply 15 vehicles to Germany. To the right you see again one of the roads in Frankfurt, which is also Hessen then. The second road is in Schleswig-Holstein, up in Lübeck, and that is also in operation. And the road down in Baden-Württemberg is being constructed at the moment, and will be finished sometime after Christmas. We divide our trucks here in these 3 lots. We will place 5 vehicles in each place, and then customer will use them in normal commercial operation. So if we look at the technology, how do we do it? If we look at the picture to the left, below the line, the interface hybrid vehicle, we have our standard vehicle. It can be our standard hybrid vehicle, it could be our standard battery vehicle, and that we don't change. To that we just connected DC-DC converter that connects to the catenary through a pantograph. So the vehicle, if the pantograph is connected, the vehicle can use the current from the catenary and also both to drive the vehicle forward and to charge the batteries. And outside the catenary, you drive in the normal hybrid or electric drive. So this means it's not a special vehicle, it's a standard vehicle with some added equipment. You don't want to raise the pantograph at any place. You really want to know that there's a catenary up there, otherwise there will be a problem. To be able to know that, we use two technologies. We have something called a zone management, where we put a zone around the electric road, and as the vehicle has a GPS built in as a standard, it can check if it's inside or outside that zone. So that means that you can't raise it before or after the electric road, only when you're onto it. So that's a longitudinal check. And then you also need to be correct in the sideways position. And there we have the ADAS system, the lane keep assist system, that knows where we are on the road and can tell the system, okay, now you're placed correctly, you're allowed to raise the pantograph. So when all these conditions are okay, then the driver can manually activate the pantograph. This is how it is today. It could be made automatic in the future in different ways, but today it's done manually. To lower the pantograph, it's lowered automatically whenever any of these conditions are not fulfilled, including the button from the driver commands to go down. So it's everything here is it's made in a safe way to make sure that you always have the catenary or the pantograph up when there's a catenary and not otherwise. And again, the power is used both to charge the battery and to drive forward. Here on this picture, you can see how we installed equipment in this generation. The pantograph is the equipment from the white box on the up. Today that is supplied from Siemens. And we make an interface box below that connects to the connects to the chassis and to the pantograph. And in that box we also put the DC-DC converter and control equipment for this operation. So again, you can see that we start with a normal truck and we put some extra equipment behind the cab. The truck is not changed itself. And that means we can build this on, in this case, it's a hybrid truck. We could also build it on a pure battery truck, build it on a fuel cell truck if we have that, or whatever. It needs to be electrified, of course. So far, we have been driving in Germany for 30,000 kilometers and 3,800 under the catenary. These customers usually have about 50 kilometers from point A to point B. And the electrified road is 5 kilometers, so they have about 10% driving on because of their drive operation. And it's generally working quite well. We have seen some issues, one with the ADAS or lane keep assist system. But today it's not perfect. They have intensive sun, sharp shadows. It mistakes the line with the shadow, and that of course can be solved. It's already sold in several passenger cars, so it's just a matter of just wait for the right equipment in our truck. But we're working on that, so that will be improved. The second thing we've seen is that sometimes the road is a little bumpy. You will get a disconnection from the catenary and then reconnection, and that could create some arcing or mainly some overshoot of the voltage when it returns. So there we need to improve the filtering, improve the software to make sure that it works. It works for trams and trains, so I'm quite sure we will also fix it. But today we see this on the road. And these two things are quite important for us as a feedback from our tests in Germany. This is why one reason why we do it, to learn these things so we can improve it in the future. And this is also to show that this is in line with the Scania strategy. We say that we are driving the shift to a sustainable transport system. And these e-highway vehicles is definitely within that message. So we have the company with us in this, that we do this. And that concludes my presentation.